Hey everybody, welcome back to yet another fun and exciting Algebra 1 class. Today we are going to be jumping into lesson 8.3, and that is on page 282, page 282. And we're going to be talking today about adding and subtracting radicals. Just like when we added and subtracted in algebra with variables for the first time, we're going to have to kind of learn some rules and remember some things so that we can do adding and subtracting. Have you noticed how in algebra, adding and subtracting has become the harder skill? Multiplying and dividing is kind of the easy skill now. And it's like, okay, what's going on? Same thing is going to happen here. You're going to look at this and you're going to go, what in the world? What am I doing? But the more practice you do, I think the easier it will become to you. Just like it's become quite easy for you to add and subtract like terms now because you've been doing it quite a bit. In a few weeks with practice, you will get good at this and you'll be able to do this without too much difficulty as well. So let's take a look at what it has to say. First of all, it uses the term, and we've heard this before, like radicals. Now, we've heard it with like terms, right? So, for instance, we cannot add 3x plus 2y. Those things don't add up. Why not? Because they're not like terms. The x and the y are different. We can't add them together. But we can add 2x plus, or 3x plus 2x. And what do we get? Well, that's going to give us 5x. Why? Because the 3 plus the 2 gives us the 5, and the x plus the x, we don't add those together. We just keep them the same. Well, the same principles right here are going to be true. All right, look here. We have the 7 square root of 5. There's the radical. And then we have minus 3 square root of 5. There's the radical. Notice that those radicals are like radicals. They're both the square root of 5, okay? So can we add these? Yes, we can, because the radicals are both square root of 5. You say, but look, a 7 and the 3, it doesn't matter, just like it didn't matter when we had a 3 and the 2 when we were adding the x. We can add the x because the x is the same. We can add these radicals because the radical's the same. It doesn't matter what's out front. We can add them because the radical is the same. So let's just go ahead and do what it says. 7 minus 3. Just like if this was x. 7x minus 3x. How would we do that? We'd say 7 minus 3 equals 4. And then we just take the x. The x doesn't change. So 7 minus 3, 4. The 5 square root of 5 doesn't change. It stays the same. That's our answer. Oh man, that's easy. Well, don't wait a second, okay? Don't get too excited yet, okay? Because it gets a little bit harder. But yeah, that's easy right there because it's almost exactly the same as what we were dealing with when we were dealing with variables, okay? What I tell students all the time is I say treat the radicals like they're variables. Treat them like they're variables because they are variables in a way. We act like they're variables when we're doing our adding, subtracting, and then you end up with the right answer, hopefully. All right, next. Well, what's going on here? I have several different things. Here's what's going on here. That's the x, that's the y, and that's the x. Okay, treat them like they're variables. Pretend they're variables. And so what can we do? In this one, we can only add the 5 square root of 3 with the minus 2 square root of 3. We can't do anything with this one. That one's just going to stay the same. Okay, so what is 5 minus 2? 5 minus 2 is 3 square roots of 3. This one stays the same, plus 4 square roots of 10. Done. You're still thinking, hey, this is easy. I like this. All right, you keep thinking that, okay? You just keep thinking that because it's gonna change real quick. All right. Let's look at this one. What do we do here? Well, it looks like we have that is the same. Let me change the color here. That is the same as that. You remember when we did this with variables? I boxed them, and yeah, we're doing the same thing. Okay, so what do? Well, now look, what's going on here? I got 2x out here and 6. What's happening? Well, here's what you want to do. You can't, now you can combine those, but you can't combine these, right? Because you can combine the radicals, but you can't combine the variables because the 2x is a different term than the 6. So here's what we're going to do. We're just going to say 2x plus 6 square roots of 7. That's all we can do. Okay. Now you could put these in a parenthesis right there. That might help you to kind of differentiate between the two because we can't combine those. I can combine the square roots of 7, okay, and that's why we only have one square root of 7, but we can't combine the 2x and the 6. All right, then what? Then we would come over here to these ones, and these ones are also like terms. So this one's different. I have 3y plus y. Those are like terms. I can combine those for a plus 4y square root of 5. This would be my answer. That's as simple as I can get that. And I know some of you love it when you get like x equals 2. You want that. You want a simple answer. But in algebra, not all of your answers are simple. Some of your answers are quite complex. So there's an example of one that you can't really simplify any further. What are some things that you should be checking on to see if you can simplify? Well, you should be checking on this and say, hey, can I reduce that? Remember last lesson we reduced those? Well, 7 is prime, so you can't reduce that. Then you look at the 5. 5 is also prime. You can't reduce that. So, yeah, you can't do anything else. All right, now let's look at this last one here. We have, this is on page, if you're following along in your book, this is on page 283. So here we go. This is, I think, example 8.3D. 8.3D. Okay, what do we do here? Well, we have a problem. Right now you're thinking, I'm just going to circle this and I'm going to go with that's my answer. It's not your answer. Nice try. All right, so what do I do? Well, here's what I do. I use yesterday's lesson or the last lesson we talked about, 8.2, and I use 8.2 here and I try to reduce these. Look, that's not a prime number. That can reduce. 50 is not a prime number. That can reduce. 32 is not a prime number. That can reduce. So what do we do here? Well, we use the last lesson and we try to reduce those out. Remember this? 4, 9, 16, 25. What are those? Those are the square factors. Okay, so we're going to square factor all this stuff. So what is the 8 simplified? Well, the only one that can go into 8 is the 4. So square root of 4, square root of 2. What's 50 simplified? Well, let's just keep simplifying this one out. Okay, so what do we get? We bring the 3 out, we bring the 2, and then we multiply it. Remember, we have to multiply that. So we get 6 square root of 2. Don't forget your minus sign. Minus. Let's simplify out the 50. Well, look right there. 25 goes into that. So 25 and 2. Now I'm going to give you a little tip right here, a little hack, a little life hack, a little math hack. All right. Here's your math hack. When you get this right here, that's probably going to be the same on all of them. Why? Because that's the like term. That's the like radical that you have to subtract by. Now, that might not work. They might give you 2 or 3 different like terms, but a lot of times, whatever that is, that's going to be the same here and the same here. So that might help you out a little bit if you kind of recognize that. What comes out here? A 5. So don't forget to multiply these, and that's going to give you 10 square root of 2 plus, and then we would come up here and finish this one, and this one would be 16 goes into that. And it goes 2 times. So what comes out is a 4, and 4 times 3 is 12 square root of 2. Now look where we are. Square root of 2, square root of 2, square root of 2. So we use yesterday's lesson to reduce our radicals in order to give us radicals that are like radicals, okay? And now that we have like radicals, now we can add them, subtract them, whatever we need to do. All right, 6 minus 10 is negative 4 square root of 2 plus 12 square root of 2. Negative 4 plus 12 is positive 8 square root of, 2. There we go. And that would be our answer. Okay. All right. Hey, a little bit of a shorter lesson today. Now, I mean, it does have some complexity to it, so you may need to go back and rewind part of it, but that's all I have for you. And so hopefully you kind of understood that. The concept is the same as adding and subtracting like terms, but sometimes you have to get it to the like term. Sometimes you have to reduce it, like this one. This 8, 50, and 32, they were not like terms, but we made them like terms. How did we make them like terms? By reducing them out by square factoring. Okay? Like I said, hopefully you learned something today. And if not, make sure you go back and review that and try some of these. Go to the exercises and try some of these for yourself. And I think that you can do these. All right, we'll see you later. Have a good one. Bye-bye.